Okay, now let's look at question 3. Then question 3 should be quite straightforward. You're given two triangles where three sides are given. So you should know that you probably will want to use the side test. So again, very easy for us to show the sides are equal. We just have to make sure the sides are corresponding. Okay, so let's start off with one side. You have xy here. Now xy we know is either b equals to BA or AB. So again, go back to the question. Remember the order must correspond. So if you have xy, okay, it must correspond to AB. And this is equals to 5.5 meter. It's the same side, so I can write S. Next side I want to look at is YZ. YZ is 13. Okay, so it's either CB or BC. Again, go back and look. YZ must correspond to BC. So we know this is equals to BC. And this is equals to 13 meters. So this is our second side. And finally, the third side, XZ, which will correspond to AC, which is 9 meters. And this is our third side. Therefore, we can say that triangle XYZ is congruent to triangle ABC. And the reason is triple S. Simple as that. Okay, now let's look at question 4. Question 4 is slightly different from the questions we've done because you're not given any dimensions. Instead, you're just told that ABCD is a parallelogram and there are two triangles here and you're supposed to show that it is congruent. So the order of the triangle is not given to us and the dimensions are not given. So we will have to look at this clue here, parallelogram. So what do you know about parallelogram? Now besides the two sides are parallel, okay, we also know that parallelogram has equal opposite sides. So we know AB and CD have to be equal. Okay, the other pair of opposite side BC and AD are also equal. And if you look at AC, AC is a common side of both triangles. So I use 3 strokes to mark this. Okay, it's equal as well. So I can look at triangle ABC and the other triangle ADC. But the problem now is, okay, how do we find the corresponding? How do we know what corresponds to what? Remember, to find the corresponding side, sometimes it helps if we can use an angle to help us. Okay, so let's say if we were to pick, alright, this angle C here, okay, BCA. Now, given a parallelogram, we know that angle BCA is equals to angle CAD. These two angles are equal. Why? Because they are alternate angles. So therefore, we know that A will actually correspond to, okay, C on the other side. Sorry, I take back what I said. Okay, now there are a lot of ABCs here, so you have to be very careful. You look at this. This C, this angle here is part of triangle ABC. So, okay, let's start again. So this angle, okay, this part C here of the triangle ABC will correspond to this point A here of triangle ADC. So C will correspond to A. Okay, C here will correspond to A. Then we look at, okay, whether there's another set of angles that are the same. Right? If you look at this angle here, okay, it will also be, okay, look at this as a Z alternate angle. It will also be equals to this angle here. Okay, this is your angle A in triangle ABC will be equals to, okay, correspond to the C, point C in triangle ACD. So A corresponds to C. And then this leaves us with, okay, B and D corresponding. So we will be trying to prove that triangle ABC is congruent to triangle CDA. Okay, remember the corresponding of the side is very important. So there are a few strategies we can use, but the easiest one, since we know that there are 3 pairs of common sides, we can use the side property. Okay, so let's start with side AB first. We know that AB corresponds to CD, and we check the order is the same. Alright, and we say that this is the first side. Okay, the next side BC corresponds to, okay, look at the order again, corresponds to DA, not AD, yeah? And this is the second side. And finally, the third side AC, okay, AC here corresponds to the other side CA. So this side. You realize that the order I write this, okay, is very important. And therefore, okay, we can conclude that triangle ABC is congruent to triangle CDA, and the reason is triple S. Okay, for those of you who are more adventurous, you can actually try and prove this. Okay, there's another way to prove this using side angle side as well.